Today, we're going to set up the MS27101 to be used with our TRX Neon system for walking a building and doing a multiple channel scan of different channels while we walk. When you first get the MS27101, you need to hook it to your computer and see what the IP address is. The IP address should be listed on the paperwork that comes in, and you're going to need to change it to fit the system you're going to be using. Like right now, if I go to the Network tab here, and I look, it's set up for a static IP address of 10.0.0.2, which is fine for a direct connection to your computer. I could set it, instead of static to dynamic, but for use with the Neon TRX system, you'll be using a micro router hooked to the MS27101, and in my case it's a Zytel. And the Zytel likes to assign IP addresses of 192.168, 100.100 and up, between 100 and 200. So I will normally set mine to 192.168, 100.101. That way it's within the range of the router, but it's static, so that if I lose power or whatever, things reboot, it won't be reassigned a different address the next time, as DHCP could do from time to time. So I will set it to that after I do some testing. And the testing I'm going to do is, I'm going to look at 4 channels today. 95.7 megahertz, 148.0025 megahertz, 739 megahertz, and 751. Each one of these will be set up a little bit differently. And we're going to start by setting for 95.7. The reason we're doing this now is so that we know the settings when we get to the final part of the setup. Because the channels you're going to scan, you're going to tell in the Android device used with your Neon TRX system. So you're going to be setting it in the Android, and you want to check things in advance to make sure everything is going to work the way you want it to. So for 95.7, because I'm going to be looking at an FM channel, what I want is a 500 kilohertz span. So I'm going to come here to my span, and I'm going to enter 500, and not megahertz, but kilohertz. There's my 500 kilohertz span around 95.7. Now I'm doing this with the antenna disconnected, and you'll understand why in a minute. Next, when I go to Amplitude and Bandwidth, I see in automatic mode it sets to 3 kilohertz. Well, I want it to be lower than that, and I'm going to manually change it down to 300 hertz. That'll give me a nice low trace. Remember, if I'm setting it for 500K, it's going to take all of this information that you see across this screen and use it to determine power. So all of this noise measurement that it sees will be used to determine power. So it's going to go up significantly, neg 125 or so, or maybe even a little bit higher, because of all the concatenation of all that frequency together. That's why you have to make sure of how you set it up, or you're going to have good readings no matter what you do. It's always good. It's always good, because you set things too high, reference level wise and otherwise. So the other things I want to make sure of is my reference level, neg 50. This is just like setting up any spectrum analyzer. No external attenuation or anything like that. And I do want my preamp on for what I'm doing. And RMS detection is perfect for what we're going to try and do today. So 300. That'll work, and I'll take note of that right now, that it's going to be a 300 hertz, because it's going to ask me when I set it up in the Android later. The second frequency is going to be a center frequency of 148.0025, and I'm going to actually have a span of 12.5 kilohertz. As if I'm looking for one individual FM channel, which is what I will be looking for. Now, just for argument, I'm going to put the antenna on momentarily for this frequency, just so you can see that there is a signal there. It's not a wide signal, it's just a small signal at 148.0025, and it's a shifting signal. Notice it shifts back and forth quite a bit. I'm not sure where that signal is coming from. It's just outside the ham band, the 2-meter ham band, into what Civil Air Patrol uses. So, and while I have the antenna hooked up, just for the heck of it, I want to go back and show you a center frequency of 95.7 and a span of 500 kilohertz. There is 95.7 FM IBOC. IBOC stands for in-band on-channel. That's these data channels that go along with this. That's what tells your car radio what's playing, what the station is, and any little happy messages they want to send to you. So anyway, a lot of people haven't seen that, but that's what the FM IBOC looks like. The next frequency we're going to look at today is 739 megahertz. So let's type in 739. But this time, our span is going to be significantly bigger. It's going to be 10 megahertz of span. Now that is a little too slow of a sweep. So let's go back to our amplitude and bandwidth here. Instead of 300 hertz, I think we can get away with 1 kilohertz for this. That's lovely. That's lovely. 1 kilohertz. So I have to remember for the bigger ones, I need a 1K RBW. And it will ask. Still with the neg 50, still with the auto. And just so you see it without a signal there, because that is a actual LTE signal that I'm picking up. It's negative, 135. And that's very good as well. Our last one here, frequency-wise, is going to be 751. Still 10 megahertz wide, so I shouldn't have to make any other changes. And just so you know that there is a signal present, if I hook the antenna back up, you will see a 10 megahertz wide signal of LTE. Although this one seems to have a birdie in it from somewhere. And I'm not sure where it's probably coming from the cell site. It's something strange going on. Could be a little bit of PIM or something along those lines, but you never know. Anyway, those are the 4 frequencies that I'm going to use. Now that I've made sure that they're going to work and I've got the settings that I want for it, I'm going to go ahead and change my network settings. Now, I can change not only the IP, the subnet mask, and the default gateway. For my purpose today, I only need to change the IP address. Keep in mind that once you make this change, if you can't get back into it, you're in a world of hurt. So make sure before you change that you know what all of these need to be. If you don't make that change. Don't make that change. Change it to dynamic and then let the router handle it and assign the address. You're just going to have to look for whatever that address is every time. But in this case, I know that I'm going to need 192.168.100.101. And once I hit apply, bang, no more response from the 27101 because I am no longer on its IP address. I'm still looking at the old IP address. Okay, I'm going to go ahead and close out of this. Now we have to assemble our package. We take our MS27101 and we hook our micro router to it. The micro router hooks to both the Ethernet port and one of the USB ports. That's what powers the micro router. We have to have our battery pack ready to go, our Android device, and our neon tracker. Once we have everything hooked together and put into the backpack, now obviously this stuff goes into the backpack. The tracker goes on your belt, and the Android device goes in your hand. And at that point, we can either program it now or go to the facility and program the channels that we want to do. All the channels will be programmed on the Android device, which we are going to do now. Now, we're going to go into the Neon Signal Mapper and start talking to everything. Now, if there's any updates for the Signal Mapper, they'll happen right now. But no problem. We're going to go to the 3 bars on the upper left so that we can start changing our settings. Now, we're already set for our tracker, but we need to go to the Anritsu settings and set these properly. First, our connection type. Well, on this one, we're not USB, we're Wi-Fi, so we have to set it for Wi-Fi. And then we have to give it the IP address that we're going to go. So we set it for 192.168.100.101. We're going to click OK on that. And we can always tap the device to connect. Connection successful. We know that we're talking through the Zytel router. Now is where we set up our scanner list, which is the last one here. Now you'll see a couple of them are in here. I'm going to X those out and we're going to start from scratch. We're going to add a channel. And the first channel that we are going to add, if you remember, was 95.7. So 95.7 megahertz. Our bandwidth is going to be 500. And we're going to set that for kilohertz. Now remember, we had changed this before. The resolution bandwidth. For the first one, we set it to 300 hertz. So we need to make sure we set that down to 300 hertz. Reference level, -50, just like we had before. Done. OK. First channel has been added. The second channel we had set for 148.0025. And the bandwidth we had at 12.5 kilohertz. And once again, this one is also a 300 hertz resolution bandwidth and a -50 level. Make sure it's OK and click OK. And now the fourth channel, if you remember, was 739 megahertz with a 10 megahertz RBW. And this time we had it set to 1 kilohertz. 1 kilohertz, if you remember, and also -50. And last but not least, 751. Also 10 megahertz, also 1 kilohertz, and also -50. I like to use -50 in most of my stuff when I'm looking for lower level signals because it's an easy one to remember and it makes sure that all the attenuation is off and the potential for the preamp is on. Okay, we're going to click OK on that. So that is good. So the device is set up. Now we have one more thing where we need to make a change. We go to the app settings, which is the one under the Anritsu settings, and display signal. What signal do we want to display? Well, obviously we want to go with Anritsu Wi-Fi and fast channel scanner. Notice there are other options. USB. If we had selected USB, depending on which machine and which unit, obviously we have all the other ones to choose from. But we chose Anritsu fast channel scanner. Okay. So we're actually all set. We could make other changes here if we want to enable Wi-Fi scanning and cellular scanning and BLE scanning. All right. But for today, that's all we need to do. We're ready to go. We're ready to go. So now, all we have to do is find out where we are. We're there. And we need to do our normal check-in. So we figure out where we're at. We do our check-in, say, okay, I'm here. And then we slowly walk our 10 meters or 30 feet. And then we'll check in again. Now, obviously, I'm just simulating this for sake of discussion. So we're checked in. Now we're checked in. We're waiting for a lock. If we don't get a lock, I'll do it again. Nope, I'll have to check in again. So we'll check in again. Add here. And then we'll walk our 10 meters. It's a little hard sometimes when you're trying to simulate it. It doesn't like it very much. And now let's check in a second time for here. Check. We now have a lock and we can start mapping. So now we would go ahead and start our normal mapping. We press play to start mapping. And then we would just start walking. Notice the channel powers keep changing. 60s, 70s, 80s, depending on which channel it is as it's scanning through them. And we would just go about our business and do our walk and do our corrections just like any other inside walk. And that's all there is to setting it up to use the MS27101 and your Neon tracker for multiple channel scanning. If you have any questions, please contact Anritsu, 1-800-ANRITSU, or www.anritsu.com. Thanks, and have a great day.